Now, this is a diagram here. It's a concentric shell figure where the inner, only this part is actually air or cavity. Here is a material of thermal conductivity 2K, and the other material which ranges from 2R to 4R has thermal conductivity of K. You can assume this as structure having this as copper, this as brass, something like this. So it's a two material concentric sphere where this is air, outside is air, okay? This is material, this is material. We know the formula, but I'm deriving it again. So dr thermal, I'm trying to calculate. Somewhere I've taken a differential hollow sphere, which we have calculated before. The way of solving is same only. For pi k you take outside. Integration is minus 1 by x, r1 to r2. So r thermal is 1 by 4 pi k, 1 by r1 minus 1 by r2. Now, if I take the first one ranges from r to 2r. So 1 by r minus 1 by 2r. And the thermal conductivity is K1. You can see that K1. So I have calculated 1 upon 8 pi K1 R. Now thermal resistance 2. The inner radius of the second sphere is 2R. The outer radius is 4R. That is what is written here. 4 pi K2. 1 upon 4R. 1 upon 16 pi K2R. Now if I add to calculate the total resistance. So R thermal 1 plus R thermal 2 is 1 upon 8 pi K1R plus 1 upon 16 pi K2R. Okay. So I'm calculating these two. The question does not require to find out this total resistance, but I have added another question just for the sake of practice to find the total thermal resistance. That is what I'm doing. But I'll come back to what is asked. What is asked is middle temperature. Okay. So R thermal 1 plus R thermal 2 is 1 upon 8 pi R, 1 by K1 plus 1 by 2 K2. So 1 upon 8 pi R, 1 by 2K, because K1 is given as 2K, as I've written here, K1 is 2K, and 2 times of K2 is K. So we got 1 upon 8 pi R into 1 by K. So 1 upon 8 pi RK. That is the total resistance if required in the question. But it was not required. Let's go back to the question. So total resistance we got as a created question. Now let's come back to the real question. This was R. This is 2R. This is 4R. So I'm converting into a resistance diagram where the inner temperature was given as 100. This was 100. This is the first rod R and 2R. So correspondingly I've drawn the thermal resistance 1, which we have calculated in previous page for each part. Then this is asked, which is Tm, and again this part is thermal resistance 2, and the other part is at 25 degrees centigrade outside. Okay, so again I've used nodal analysis. Tm minus 100 divided by R thermal 1, Tm minus 25 divided by R thermal 2. We've calculated it. Tm minus 100, 1 upon 8 pi K1R. See, we calculated these two. 1 upon 8 pi K1R. Okay, and then I'll use 16K pi QR. See, 1 upon that, because that is what we got the answer as thermal resistance of both. So now I can easily calculate 8 pi R can be cancelled. So I'll get a 2 here. Okay, then K1 can go up 100 Tm minus 100. 2 can go up, K2 along with K2, Tm minus 25 equal to 0. So 2K gets cancelled because K1 is 2K, K2 is K, but both become same 2K, so you can cancel it. So Tm plus Tm is 2Tm, 100 plus 25 is 125. So Tm is 62.5 degrees centigrade. That is the answer of the middle section temperature.